All right, so code of conduct first. Welcome to the IBM Cloud Kubernetes SIG bi-weekly meeting today on Wednesday, May 8th. My name is Sahdeh Zala, and I'm your meeting host today. Before we start the meeting, I would like to remind you that please keep in mind that this meeting is a public meeting and it's being recorded and made available to YouTube afterwards. So be considerate of what you say. With that, let me share my screen so that I can share agenda and few other things. And can everybody see my screen? It's good?
Yep.
Yep. Okay, perfect, thanks. So in the agenda, what we have for today is Zoom is covering on one side of my browser, but please add your name if you can. If you're not, the URL available, I will add the name later. I guess we don't have any new members. It's all regular peeps, so we can skip the introduction part. And we can go straight to the next item in the agenda. And I'm very excited, and Brad, you can make this announcement because you've been doing lots of, you having lots of involvement here with reviews and ongoing things with the cluster API provider IBM Cloud project. It became our first sub project of the SIG just a few days back, and I will be talking a little bit about it, giving an overview of the project. Brad will be adding more stuff there from architecture point of view. Guangjia, who is in China, he's the creator of the project. Wanted, or I wish he could present, but because he's in China, the time difference, I didn't want him to work. So Brad and I will take that, take that load to present. And then we're gonna have Khalid talking briefly about integrating HPC schedule in Kubernetes, and then a little bit about upcoming KubeCon activities from SIG perspective. And then we can have some open discussions as we go forward. Please interrupt me if you have any question anytime. But here, I don't have any slides. I did not create purposefully because lots of material is right here online. So like I said, we have created our first sub project. It's right here under the SIG IBM Cloud README. So before I talk about the project itself, why we have it, and a little bit about it, just as in background. As we know, more and more requirements are emerging as Kubernetes adoption is growing, and innovative things like CRDs are helping come up with many different solutions, right? And the Cluster API project, before we talk about the IBM Cloud provider project, the sub project I mentioned, let me mention a little bit about the Cluster API project. So that's the main project, which was also born under search and requirements. So as we know, for hybrid cloud and multi-cloud environments, we need Kubernetes native way to help end user manage the cluster in different cloud providers like AWS, IKS, Azure, and others, right? As we know, again, folks on this call are all familiar with Kubernetes, and pretty much all of us contributing to Kubernetes one way or other way. As we all know, Kubernetes has a common set of APIs to orchestrate containers regardless of deployment mechanism, right, or the cloud provider. And there are also APIs available for handling some of the infrastructure needs, like load balancers, right, ingress rules, and persistence, volume, etc. One thing which is which is like out of scope is creating new machines, right? And that's where the Cluster API project comes in picture. basically to build a set of APIs for cluster management to enable common lifecycle operations, like creating a new cluster, adding new machines, deleting new machines, new nodes, and that kind of things. Okay, so that's the cluster API project, and you can read more about the project itself on this GitHub repo. There's a pretty picture there about multi-cloud sort of need for the cluster management, a lot of other things here. But as you can see, different providers has their own implementation because every providers are different, right? They have their own way of doing things. And it's what I mentioned earlier, IBM Cloud has its own project out there now. And that's what we're going to talk a little bit more about it. So that's the link I have open right here, the first API provider, IBM Cloud. And you can see a bunch of things here. Again, the best place to learn more about it. But let me just sort of walk you through some of these titles here, the subtitles and sections. Again, like I said, I don't have any charts or anything, but we'll use this material. So this is a project for Kubernetes style APIs for the cluster creation and configuration management in the IBM Cloud environment. Couple of things here for if you are interested, follow the Slack links. There's a mailing list as well. You can be part of it to get updates. A bunch of things here. We're not going in detail. Again, just overview today. I'm by no means SME here in this topic. Whatever I learned working with Guangya is what I'm talking about. And based on some of the discussion with Brad. I'm sorry, Brad, is that you?
Well, I was going to say, let me know when you want me to go a little deeper for you.
Yep, no, I will, yeah. I'm just giving a little overview, Brad, and then you can take it.
Okay.
Yep. Yeah, so, kubectl or kubectl is what you're going to do a lot of things with. There's one more tool here, as you can see, cluster CTL, and, there's here the cluster, where is it? Yeah, actually cluster CTL here. You can read more about cluster CTL there, but you're gonna use the cluster CTL tool to create the cluster and manage the cluster itself, like adding new nodes or deleting new things. So Brad will talk more on architecture, but just on high level, you need some of these files, which you can see here, like machines as YAML, which I'm going to show a little example right after I go through this thing. But what you're going to do is you're going to create a cluster using kubectl like this, right? Using the bootstrap cluster in between. And you can use Minikube kind or other existing cluster configuration to create your a new cluster from scratch. That's the time you're gonna use a bootstrap cluster. But to me, this is more interesting. Before again, we go. This is a little bit YAML here. So as I said earlier, project uses CRDs. So here you can have like a machine list CRD created the kind. And then as part of that, you basically define what you need, what kind of machine you are creating. Here, you're creating a master node, and then you're providing all the spec here, what you need for your new node. In the same way, you can have another machine created, which is going to be your regular node, and you have a spec for this node to be created.
Well,
So
I wish I know this. I wish I know this earlier.
Well, Shushan, what the project, the sub-project is just announced last week.
Yeah, it just showed up, so don't feel bad at all.
Okay, yeah, because we spent a lot of time writing our own script, but this one is much easier. This one is much easier.
Yeah, and it's standard, right? So, which is really cool.
Brad, you can take it over from here.
Yeah, let me share my screen.
Sure, let me stop sharing mine.
Okay. Okay. Okay, so I should be able to share. All right, so y'all can see my screen.
Yes.
Okay, so this is really cool. So basically, you've got a project, as Sadev said, where the goal is to provide a declarative model for actually getting your cluster up and running. And how the project is structured is it's really neat. There's a base project called the cluster API, and that's sort of the core, and it'll have a lot of your basics in there. And then so you have that project, and you'll see how some of the code inherits and uses some of the classes from the base project. And then the providers, all the different providers now provide a provider thing, which is sort of what what we're going to start talking about. And so, I haven't looked at this much because I've been very, very busy, but let's just, go play around here. So a couple interesting things. The model is such that, and this is I tweeted about this because it's like a simulation inside a simulation. You're going to get a bootstrap cluster up and running, and then from the bootstrap cluster, then you'll get the actual cluster up and running, say the IBM cluster up and running, and then the bootstrap cluster goes away. That's sort of the overall structure. And everything's done with the controllers, right? So hopefully everybody kind of knows what a controller is. You got a controller, and basically that's a nice interface that allows you to create, update, or delete your customized resources. And a couple interesting things. So if you look at the basic structure here, I'm going to go into command. Everybody can see my screen, right? So, so one thing I noticed that was interesting about the architecture, you have all these different providers providing the cluster API, and that's the cluster control. But for what I'm sure is just to make sure life goes smoothly, every API provider, so we're cluster API provider, IBM Cloud, is supposed to provide their own implementation of that cluster control. And so if you go down here into command, you can go down here and see that's where ours is, right? And I haven't even looked at what the code is yet because this is kind of fresh. And by the way, Guanya has been leading this effort. We've got this, at least this minimum viable thing up and running, and very quickly. So that's really exciting. So that's one key part, and then I'll go show you the other key parts. So the funny thing about these projects is there's a whole bunch of code that you don't necessarily have to learn, right? Well, I mean, I guess you do, but there's a whole bunch of code in the core project, the cluster API one. They're providing the CRDs and some basic things that you can end up using. And eventually what what Guanya is going to have to build, all the main code goes into what's called, let me find it, the actuators. So inside in the control loops where you've got your create, update, and delete, eventually for cluster and machine, you've got these things called actuators. And the one that I think a lot of work is being done so far is in this actuator here. So you can see he's starting to get some soft layer stuff, because eventually this is going to go down to, for an IBM cloud, it's going to be starting something up on soft layer. It's going to define some constants, what state are things in, machine pending, creating, running. And now we start to see, this is where Mike and Chris Luciano start laughing because they can't believe I can actually look at code, right, guys? But I can. So if you look at what's going on here, you've got, your create method, right? So we talked about having a create method. So somehow if we dig into here, I bet we're gonna hopefully create a virtual machine is what I believe. And then we've also got a delete method. So we've got to delete, and ideally there's gonna be a way to delete that machine. And again, I am doing this by the seat of my pants, folks. I haven't looked at this code, but I looked at some early stuff way on, but I haven't looked at this quite a while. So this is just kind of fun. And then there's the update method here. So if we need to update, a machine for a cluster, check whether it exists, be able to get the IP address. So there's some basic APIs here that need to be implemented. And I thought there was a reconcile as well. So this is the main code's going to be in these actuators. This is the machine actuator. And then if I go look, let's see what we have here. Let's go find another actuator. So if I go here, I'll cheat and make it easy. So we've got the actuators, that was a machine actuator, then there's a cluster actuator. So if we go look in here, there is a reconcile loop. So if you look at the architecture, and I would have to ask one, I don't know why the other one didn't have a reconcile loop yet. Not a lot of code implemented here, but eventually this is going to get filled out with being able to reconcile if another YAML comes in, you'll be able to reconcile what's supposed to happen to your cluster. So this is all using standard Kubernetes controllers. We can go look at the pieces, but there's a lot of places where, let's go look at the imports. So not in this one. Let's look in the machine actuator. SIG Kids, Cluster API, IBM Cloud. Somewhere, oh yeah, Cluster V1. So if you go look Cluster V1, there's an example where they're picking up the references to that base project, right? So if we go look, Cluster V1 is there, and let's search for it. I bet you it's used in here somewhere. Cluster V1. Oh, 34 times. Jackpot. So you can see, when it's doing the create and the context. So it's this classic structure of there's the core project that everybody in the community contributes to, right? That's the cluster API. And then you plug in your provider, and the bridge between the two is these methods and passing in these structures like the cluster V1 cluster and the machine, the cluster V1 machine. So those are all defined in the base repo for cluster API, and then all the different providers are all using the same stuff, which I thought was really cool, right? So you got a nice standard implementation, standard API, and everybody just plugs in the provider. And so if we go look at where a cluster V1 is being used, into all the methods it's getting passed in there as well. Get guests. So everything's using those standard APIs, which is cool. And then if we go look, let's go look somewhere else to get a little more interest into how this all structure sets up. If I go to Cluster API Cloud, and let's see if I go into package, and I go look in the controllers here. So these are these main hooks. So the add cluster controller hook, let's look at what's going on here, right? So it's that classic structure of you're going to have a list of functions that get added to the manager, and add with actuator. So, you know, these are the hooks that make it all work from that base project to your project, and it'll set up. The other nice thing is, so it's using the Cube Builder to handle sort of the attributes of the method. So you get your RBAC here, and you know, other features that are all using these specialized comments if you've used Cube Builder. Other cool things that it's using is Customize. How many folks are pretty familiar with the Customize? Is everybody familiar with Customize? So it's also using the Customize. Let's see if we can go look and find that under APIs, maybe. I'm trying to think where the YAMLs are. Hold on. Bear with me. Probably in config. Thank you. Who told me that? All right. So this was kind of cool as well. You know, there's different ways to do configuration. You got your Helm charts, and they allow things to be parameterized. But now there's this thing called Customizer, which is really good at taking base YAMLs and being able to describe how you can then patch or update the base YAMLs. And it's sort of a newer approach in the Kubernetes land for being able to do customized, parameterized configuration. And let me see, if I go to the default, you've got a customization YAML. Now, just for giggles, Chris and Michael, have you all been using Customizer now? Or heard of it or anything?
I can't remember if it was Customize or what are some other CRD builders that are popular?
I don't know. This is the other one. So we'll take that as
I heard about it, Brad. I
Okay.
think it's a sub-project of the CLI.
Yeah, it is a new sub-project of CLI, and we're going to put Chris down as a no. Sorry, Chris. Now, Michael, have you heard of it?
I have heard of it, yes.
You've heard of it. So let's see.
We have some discussion.
Yes.
I'm not quite sure is the same customize. But we have some discussion about regarding use Helm to create the base YAML file and use customize to overlap. Just overlap the customization.
Yeah. Exactly, and that's what it's there for. It's sort of like the ability to overlay and patch and do some cool things. And I haven't looked at this in quite a while, so I'm trying to remember if I can even attempt to read this. The resource, I believe, are hey, here are the YAML files that we're going to end up tweaking or modifying. And then you actually get to say manager image patch.yaml. We can go look at those, but I think those are saying, hey, these are the patches. These are going to contain the things that we use to update. And then you can pass in variables. So now we got a name of a variable, webhook secret name. It's a secret. And so that'll be something you can go pass in. And so if we go look, here are your patches. So if I go look at manager image patch, you can use this one to actually change the value of the image field. So you put your value here, and it'll actually put that into the other YAMLs where everything matches. So that'll be used, I believe, where it's a stateful set, and you know, for the controller manager on the system namespace, it'll take that value and change it in there. So Customize is really cool. I'm going to go back. So that's the config default. And then if we go look at the RBAC just for fun, you can see what's going in the RBAC YAML, all the things. And I'm trying to see if that's probably the end result of applying the patches, I believe. So a little more to learn there, and if I had done any prep at all, I would have done a much better job. You've also got your CRDs. So again, the CRDs will get generated. I think they used, I want to say Kube Builder. I want to say Kube Builder is what they used to generate the CRDs. So You've got your custom resources and your APIs for being able to do your cluster things and your machine things. And so we'll, obviously if we had Guanya here, he'd do a much better job of explaining all this. But what I believe is going to happen is you'll see a lot more code show up in those actuators, right? I believe that's where all the guts of what's going to happen for being able to control your cluster. So when this all gets filled out, you're going to be able to read in the YAML, and it's going to say a declarative way to describe, here's what your cluster should be, and then all the stuff will get called, the actuators will get called, and you'll be able to either create machines and or clusters. And that'll be really cool because a lot of the other Kubernetes platforms are starting to make progress. There was several weeks ago, and it's out on YouTube, they did a demo of the one for Azure. And it's just kind of a nice feature, right? Everything else is done declarative. Why not create your clusters and machines? So Sadaf, I hope I did not butcher that. I apologize. I did not prep for this, but I just figured, what the heck? We just kind of go look at some code. Because, yeah. Any questions?
No question, but that was great, Brad. It was very, very, very nice walkthrough in a short notice. So that was really good.
Yeah, and then, right. And then I'm sure the other people know the vendor stuff, everything in that is using classic Go, you copy that in there. Scripts, you got some scripts here to build images. Because there's a whole bit, there's a little bit of Docker code in these cluster APIs as well, because you end up having to build an image as part of it. So there's some cool stuff to go look in the build image as well. Sorry about that. So, but Sadaf, I think I tried to do my brief overview there without embarrassing myself too much.
That was great. I'm sure everybody got a really good understanding, and being this project new, right? So this is really good. As Brad said, this will evolve a lot. Right now, it has limited support for a lot of things, but you can look at the issues. There are issues created for a better, integration between, different for the hybrid cloud environment and that kind of thing. So,
right. And then just to clarify one thing, for the two different actuators, for the cluster one, I think that the key methods are reconcile and delete, and then for the machine actuator, it's create, delete, update, and exists. So those are the things that I bet you Guanya implemented, because he's way better at reading and implementing specs than I ever will be. All right, go ahead, Sadaf.
All right, cool. Well, thanks again, Brad. Guys, if you have any questions, we can, ask anytime. If not, I guess we can move with the next topic.
Yep, and I'm going to stop sharing, so hopefully someone else can share if they want to.
Perfect. Yeah. Thanks, Brad. Yeah. So next in line, Khalid, you want to brief about?
Sure. Yeah, I'll give a 7 minute talk. This is just kind of a heads up to the team and anybody who's in the SIG IBM Cloud. It's kind of work that we're started off kind of late last year and just kind of kicking it into gear and making it available externally. So Kubernetes is a great tool that's being used a lot in the kind of the microservices world and web services and those kinds of things. So we're looking to expand the kind of use cases that Kubernetes is able to deal with, and high performance computing is one of those use cases. And when you think of HPC or high performance computing, you might think of the supercomputer type of applications and so on, with modeling and simulation that is run by the Summit and Sierra supercomputers that were announced a few months back at the Department of Defense and Department of Energy. But actually, HPC is also used in commercial centers in financial services and manufacturing and so on, in terms of modeling and simulation used to design products. So the HPC world and the cloud or the Kubernetes world have largely been kind of evolving separately. And what we're trying to do in this effort is to bring together, let me just share kind of some elements of this. So share his chart. So one of the sure. So one of the key aspects of in the HPC stack is kind of the scheduler, right? And we know Kubernetes has a default scheduler that is able to schedule pods and stateful sets and deployments and those kinds of things. But what we're in the HPC world, these schedulers are fairly important in terms of managing the workloads and the jobs and all the applications that the HPC community typically deals with, MPI workloads and specialized workloads like that. But the core kind of scheduling logic and algorithms and so on are fairly rich and sophisticated. And rather than trying to say that you have to replace the HPC scheduler with Kubernetes, the idea is to try to bring these together in some meaningful way that adds value to the HPC stack as well as in the Kubernetes stack. So what we've done is to show, and there's a number of HPC schedulers out there, right? IBM has some, and there's a bunch of open source ones like Slurm and PBS and so on. So this model that we think that we approach the scheduling aspect with applies to open source schedulers as well as the IBM schedulers. But basically what we've shown is that, and there's it's public described in this site, in this GitHub link. I'll just kind of show it to you and show you the architecture. But basically the idea is that you can bring in more sophisticated resource sharing and resource management policies that allow you to control qualities of service like SLAs, like gold, silver, bronze, and so on, or prioritization and so on, in a way that is non-disruptive to the HPC world as well as in the Kubernetes. So these two stacks can kind of eventually, we think, work towards convergence. So there's integration that we've done. You guys can see the Chrome.
Yep.
Here, yeah. So what we've done is kind of added bridges between the HPC scheduler and Kubernetes. So there's basically a driver that listens to the Kubernetes API server. It looks for pods that need to be scheduled, and obviously Kubernetes allows multiple schedulers. The default scheduler is replaceable, or you can augment it. So we have a scheduler that's based on the IBM technology as an example, but obviously this can be extended to other open source schedulers as well, right? So the idea is to leverage the extension points of Kubernetes, things like annotations and scheduler names and custom resources as well, that allow you to express the requirements for HPC-like workloads, so AI workloads, machine learning, deep learning, even things like in a highly dynamic environment where you have interactive analytics with notebooks, or even CI/CD if you're using Jenkins that is spinning up a lot of pods within your clusters, and you need to be able to prioritize it. You need to be able to queue them and manage their dependencies, etc. You can by plugging in these more advanced schedulers through this model, you can basically get the scheduler to make the decisions about where to place them, where to run them, and when to run them. But then in a way that's transparent, Kubernetes will handle the execution of all the components or all the pods, right? So from the point of view of logging, monitoring, debugging, troubleshooting, etc., it's all transparent to Kubernetes. Right. So this is an example of a deployment where we're bringing in the HPC scheduler into Kubernetes and connecting it. We also support a deployment model where you, if you have an existing HPC environment, you can bring in Kubernetes into that environment and use it to run, the various long-running services or the microservices of those applications, and merge them with your existing HPC environment in kind of a more smoother way, right? So this integration is available. It's a technical preview now, and we'll be publishing more things around it, right? So there's at this site LSF Kubernetes. LSF is the IBM scheduler that we've done this integration with, and it provides a bunch of policies that the other open source schedulers also have some of these policies as well. But it brings that in and allows you to connect to it and use a more advanced scheduler within your Kubernetes environment to support workloads that are a little bit different from the typical Kubernetes workloads today. Okay, so that's a quick overview. In the future, I can give more details on it if there's interest and so on. But so we'll be continuing to iterate on this and make this available to the community to try. Okay, any comments or questions?
That was great, Khalid. Thank you so much. I don't have a question, but a comment. Can you paste that URL in
Yep,
the
I'll add it to the thing.
notes, please? Yeah.
Yep, great. Thank you.
Yep. Thank you. And it's open for questions, as you said. So anyone has any question? Okay. Well, seems like no question, but that was very educational. With that in agenda, I guess let's keep going on. Just very briefly, the KubeCon Barcelona is it's very close by now. Not next week, but the following week. And I just want to mention, the SIG activities we'll be doing at Barcelona. As you can see, the agenda. I'm not sharing screen for just that now. But we will be having a SIG intro plus deep dive 80-minute session. We are pretty much there with the charts. Good charts so far and other content. And it will be in a presentation plus discussions, 80 minutes, a lot of good stuff hopefully will be happening there. Contributor Summit, we'll be doing a couple of things. We're gonna have a 3 hours, it's not a session, but a room for 3 hours to do any SIG related activities, brainstorming, future roadmaps and that kind of things between contributors. So, if your schedule allow, please join the SIG meeting there. And we'll be also having, we will participate in the SIG meet and greet session. Typically it's 30-minute sessions for new contributors. So the idea is, there will be a new contributor workshop. And as part of that, this 30-minute session, different SIGs will have, the participant SIGs will have their own table, like round table, and new contributors can stop by, learn more about the SIGs and, how they can contribute, right? Because every SIG loves having more contributors. So we'll be participating and, looking forward to meet some new contributors. In last KubeCon, that's how I met Marky. He is a colleague of Shishang. So I met him at the SIG meet and greet. So that was really good. So that's pretty much about the KubeCon Barcelona. For the intro and deep dive, I think just to add one thing, it's gonna be Khalid, Brad, myself, and Nimesh talking about this session. Richard is not going, so he, otherwise he was one of the speakers there. But that's pretty much about Barcelona, and that brings us to open discussions. Any other topic we want to talk about? Okay, well, I think that was a good 45 minutes meeting. So if there's no other questions, no topic, that's it for today's meeting. And we can, I think, resume after KubeCon. So I'm gonna cancel the next one, the next bi-weekly meeting, which is happening in mid of KubeCon. So I'll cancel that, but we'll meet after almost 4 weeks from now.
Yeah, so I understand you're going to cancel the next one, but when you guys come back from from the KubeCon, well, any chance you can share with us? Well, probably in this case me, the audience outside of IBM, what you guys hear in the KubeCon, what is the trend of the market, and especially those topics are relevant to IBM Cloud.
Absolutely, Sisang. I think that would be a good topic for the follow-up meeting after KubeCon, right?
Mm-hmm.
I think all of us who are going there, they can share their own experience. We can create like a little doc kind of thing, or just put in the agenda. But yeah, we can share, the output of activities around IBM Cloud SIG, and a little bit around IBM Cloud sessions that would be presented there. So I think that sure we will do that. It's a good idea.
All right, cool.
Sure.
Thank you, guys.
Yep. No problem. Anything else? If not, then Brad, you want to add anything? I think we are all set for the KubeCon now. So
No, yeah, I think we're all set, and it should be a good presentation.
yep. Looking forward. Alrighty. Well, with that, I think time to say goodbye for today's call. So thank you so much, everyone. Goodbye, and talk to you later.
Thanks, Adam. Thanks.
Yep. Thanks, Khalid. Thanks, everyone. Bye.
Guys.